This is lesson 1 of unit 5 on exponents. So this first lesson we will be talking about specifically the exponent rules. So in multiplication, the terms that are multiplied together are called factors. A repeated multiplication of equal factors can be expressed as a power. Okay, so if we're looking at this example here, it says 3 times 3 times 3 times 3. So that, if I were to write that multiplication, right, we have the factor of 3 multiplied 4 times. So I can write that as a power because it's a repeated multiplication. So how I would write this as a power is 3, right? 3 is my base, 3 is what I'm multiplying, and I'm multiplying it 4 times. So that's the same as 3 to the power of 4. Okay, and if you simplify that on your calculator, you will get 81. So in this situation, the whole thing, 3 to the power of 4, is the power. Okay, 3 is what we call the base, and 4 is our exponent. So that should be review. Okay, looking at a couple examples here. It says write each in expanded form and then evaluate to standard form. So expanded form, it just wants you to write out what this actually means, just like it had above here. So if we have 6 to the power of 3, 6 is our base. So our base is always what we're multiplying, and we're multiplying it however many times the exponent tells us. 6 times 6 times 6 would be our expanded form. And if we typed in 6 to the power of 3 on our calculator, or 6 times 6 times 6, we'll get the same thing, 216. Okay, this next example says 3 to the power of 2 times 2 to the power of 3. So we have our first power is 3 times 3, right? 3 twice. And that's going to be multiplied by our second power, which is 2 3 times. Okay, so you can simplify that on your calculator. 3 times 3 is 9, right? Because we're following BEDMAS, so we have to deal with those brackets first. 2 times 2 times 2, or 2 to the power of 3, is 8. 9 times 8 is 72. Okay, and the last example here. 6 squared plus 3 squared. So we can't use any sort of power law here, which we will learn below. We have to first write this in expanded form. So 6 to the power of 2 is going to be 6 times itself, right, just twice, plus 3 to the power of 2, which is 3 times 3. So we have 36 plus 9, which gives us 45. Okay, moving on. So it says power of a negative number. So exponents affect only the number it touches in a power. So this first one, we have negative 3 squared. Okay, because that negative is out front, that power is not touching it, right? So what that actually means is we would leave the negative out front and we would have 3 squared. So 3 times 3. So that would give us an answer of negative 9. If, on the other hand, we have our negative 3 in brackets, that means that 2 is touching, supposedly, that whole number, right? So what this one would actually be is negative 3 times negative 3, which would give us a different result, right? Because I'm multiplying 2 negative numbers together there, I would end up with a value of positive 9. Okay? So for this one, the last one here, it says consider x minus 2 to the power of 2. So again, that squared is only affecting what it's touching. So this is going to be the same as x minus 2 times 2, right? Which is just x minus 4. if my negative was in brackets there, it would be a different story. But right now, it's just representing subtraction. Okay, so you just have to remember that if it's in brackets, you apply the 2 to the whole number. If it has it just out front, think about it as simply subtraction. Okay, so let's define our exponent laws. So if we're adding or subtracting powers, you can only add and subtract the coefficients of the power. Coefficients. Okay, so what that means is if we have a to the power of m plus a to the power of n, we can only add our a's together. So it would just be 2a to the power of m plus n. We can't actually simplify this together. Okay, so for this example, a to the power of m plus 3a to the power of m, because those are both m's on top, we can simplify them. Okay, so we can simplify the coefficients and the exponents. So the coefficients here, when we don't see a coefficient, we always assume it's a 1, right? So this is 3 plus 1, which is 4a, and m plus m, which is 2m. If I had a question that had, like say this was an n, I wouldn't be able to put those two together. So that's when we're adding. When we're multiplying powers with the same base, we need to add the exponents. Okay, so if I have a to the power of m times a to the power of n, my answer is a m plus n. Okay, so I'm not doing anything with the coefficients here. I just have to add my exponents. So here I have 2 powers with the same base, right? Those are both x. So all I have to do is add those exponents. So that is just the same as x to the power of 5. Okay, if I'm dividing powers with the same base, I need to subtract the exponents. Okay, so if I have a to the power of m divided by a to the power of n, my answer is going to be m minus n. Okay, so x to the power of 7 divided by x to the power of 4, all I have to do is subtract my exponents. So x to the power of 7 minus 4 equals x to the power of 3. Okay, the next law is called power of a power. So this rule says if we're simplifying a power of a power, we must multiply the exponents. Okay, so if we have a to the power of m in brackets, and that whole thing is to the power of n, what we need to do is we need to multiply the exponent. So it's actually a to the power of m times n. So looking at this exponent, we would have x to the power of 4 times 3, which is x to the power of 12. So we're always going to take that extra step in fully simplifying. Okay, last one is power of a product or quotient. So what we need to do here is we need to apply the exponent to each term in the product or the quotient. Okay, product is just a result of multiplication. Quotient is just a result of division. So don't think too much into the name of it. Okay, so if we have in brackets a times b to the power of m, our definition tells us we need to apply that m to everything inside of the bracket, to each term, right? So this is going to be the same as a to the power of m times b to the power of m. Okay, so that's 1/2 of it. If we have a fraction or a division, we must also apply that m to both terms. So this would be the same as a to the power of m divided by b to the power of m. Okay, so looking at these examples, again, we need to apply that 3 to both the x and the y. So this would be x to the power of 3, y to the power of 3. Remember, this is the same as multiplication, but because our bases aren't the same, we can't apply that power rule, right? We can't say, oh, okay, I'm multiplying these, that means I have to add the exponent. That would only be the case if this was the same variable. Okay, and last one here, again, applying that to both parts. So we have x squared over y squared. Okay, and this is a very short note, so this is the end of the first lesson on exponent rules.